Hey there and welcome. So today we're going to tackle something that can feel like a really big, kind of weird step in math. You know, that moment when all of a sudden there are letters. If you've ever looked at that and felt a little bit confused, trust me, you're not alone. But don't worry, we're going to break it all down and make it super, super simple and clear. Seriously, have you ever had that moment? You open up your math homework and you're just staring at it thinking, hold on, I thought math was about numbers. What are all these letters doing here? It's a totally fair question, and I promise almost everyone asks it. So let's get into it. Okay, so let's start with something really simple. Biscuits. Imagine you've got a box, and inside there are exactly 10 biscuits. Now, if you have 2 of those boxes, how many biscuits do you have in total? You got it, 20. What about 3 boxes? Yep, 30. But what if I told you I have a bunch of boxes, but I'm not going to tell you exactly how many? It's a mystery number. Well, in math, we need a way to talk about that mystery number. So we just pick a letter to stand in for it. A really popular one is X. So the total number of biscuits would just be 10 times X, whatever X turns out to be. And that letter, that X, it has a fancy name. We call it a variable. But don't let the name scare you. All it is a placeholder. That's it. Think of it like a little box or a sticky note that says, a number goes here, we just don't know which one yet. It's just saving a spot for a number until we figure out what that number is. Okay, so we get it. Letters are just placeholders for numbers. Now let's get to the cool part. Algebra is actually all about making math faster and easier to write. You know how you use shortcuts when you're texting, like LOL or BRB? Well, algebra has its own set of shortcuts to make things way simpler. So let's go through some of these super useful multiplication rules. First up, we can just hide the multiplication sign. So instead of writing 3 times x, we can just squish them together and write 3x. Way cleaner. Second rule, the number always goes first. So you wouldn't write x times 2, you'd flip it around and write 2x. Think of it as being polite. Numbers go first. Third, if you're multiplying different letters, like B times A, we just put them in alphabetical order, so it becomes AB. It just keeps everything neat and tidy. And the last one for now. If you have a letter times itself, like A times A, we write that with a little power. It becomes A squared. It's just a shortcut, so we don't have to write A over and over again. And you know what? Division is even easier. We pretty much just get rid of that division symbol altogether. Instead, we write it like a fraction. So if you see x divided by 5, you just write it as x with a line over the 5. That's it. It makes everything look so much neater, doesn't it? Awesome. You're doing great. So we know how to write these new expressions. But what's the point? Well, here's where it all comes together. Now we're going to learn how to actually use them to find answers. We do this by plugging in the numbers we know. Now, this plugging in process has an official math name. It's called substitution. But again, don't let the fancy word fool you. It literally just means we take our variable, our little placeholder letter, and we swap it out for an actual number. And that final answer you get at the end, we call that the value. Simple. Let's do one together, you and me. What if we have this expression, 25 plus 300x, and then we're told, okay, for this problem, x is equal to 2. All we have to do is take that 2 and put it right where the x is. So our expression becomes 25 plus 300 times 2. First, we do the multiplication. 300 times 2 is 600. Then we add the 25. So 600 plus 25 is 625. That's it. That's our answer. See? You totally got this. Okay, listen up, because this is a super duper important tip. This one little trick will save you from so many mistakes later on. Ready? Whenever you substitute a negative number, you have got to put it in parentheses, always. Let's look at why. Say we have the expression minus a plus 4, and we're told that a is negative 3. So we substitute, but we use those parentheses. It becomes minus the negative 3 plus 4. See those two minus signs right next to each other? They turn into a plus. So it's really just 3 plus 4, which is 7. If we forgot the parentheses, we might have gotten the wrong answer. You are absolutely cruising through this. So, what's next? Well, sometimes our math expressions can look a little messy. So we need to tidy them up. I want you to think about it like sorting your laundry. You put all the socks in one pile, all the t-shirts in another pile. We do the exact same thing in algebra. And these things that we can group together, we call them like terms. The rule is super simple. For terms to be like, they have to have the exact same variable part. That means the same letter and the same little power attached to it. And what about plain old numbers with no letters? Well, they're like terms with each other. All the plain numbers can go in their own pile. Okay, let's look at some examples to make this crystal clear. Over on the left, we have 3x and 5x. Are they like terms? Yes, because they both have an x. What about 7y squared and negative 2y squared? Yep, they're like terms too, because they both have y squared. And of course, 10 and negative 4 are just plain numbers, so they're like terms. Now look at the other side, 3x and 5y. Not like terms. Why? Because one has an x and the other has a y. They're different. And this is a tricky one, 7x squared and negative 2x. They both have x, right? But one is x squared and the other is just x. Those powers are different, so they are not like terms. So what do we do once we've found our like terms? We just combine them. It's just adding or subtracting. You only pay attention to the numbers out in front. We call those coefficients. So if you have 3x plus 5x, you just think, what's 3 plus 5? It's 8. So the answer is 8x. It's exactly like saying, I have 3 apples, you give me 5 more apples, now I have 8 apples. The apple part, or the x part, doesn't change. All right, you're doing so well. We've mastered expressions. Now we're ready for the next big step, equations. And to understand equations, I want you to picture one of those old-fashioned balance scales in your mind. You know, the kind with the little dish on each side. That's the perfect way to think about an equation. So what's an equation really? It's just a math statement that has an equal sign. That's what makes it different from an expression. And that equal sign, that's the center point of our balance scale. And here is the one most important golden rule of all of algebra. You have to keep the scale balanced, always. So how do we make sure our scale stays perfectly balanced? Well, there are 4 basic things we're allowed to do. If you add something to one side, you have to add the exact same thing to the other side to keep it from tipping over. If you subtract something from one side, you've got to subtract the same thing from the other. Same for multiplying, and same for dividing. Whatever action you take on one side of that equal sign, you must do the identical action on the other side. That's the rule, no exceptions. Okay, deep breath. This is it. This is the moment we've been working towards. We've learned about variables, we've learned how to simplify things, and we've learned the all-important rules of balance. Now, we're going to put all of those skills together to finally solve the mystery and find out what x really is. But before we solve a big one, let me show you a really cool shortcut. It's built on those rules of balance, but it makes things so much faster. It's called transposition. Basically, it means you can pick up any piece of the equation and move it to the other side of the equal sign. The only catch? When it crosses the equal sign, it has to flip its own sign. So a plus becomes a minus, and a minus becomes a plus. It's like a little magic trick. All right, here is our game plan. A simple 4-step recipe that's going to help us solve a ton of these equations. Step 1. If you see any parentheses, your first job is to get rid of them. Step 2. We use that transposition trick to get all the letter terms on one side, usually the left, and all the plain number terms on the other side. Step 3. Tidy everything up by combining all the like terms on each side. And finally, step 4. Do one last move, usually division, to get that variable all by itself so it can tell us its secret value. Okay, let's put our recipe into action with this puzzle right here. We've got 4 times x minus 2 on one side and 5x plus 2 on the other. So what's step 1 of our game plan? Get rid of the parentheses. So we need to distribute that 4 to everything inside. First, 4 times x gives us 4x. Then 4 times minus 2 gives us minus 8. The other side of the equation just hangs out for a second. Okay, parentheses are gone. Now we're looking at 4x minus 8 equals 5x plus 2. Time for step 2, sorting. Let's get all the x terms to the left. That 5x on the right needs to come over. Since it's positive, when it crosses the equal sign, it becomes a minus 5x. Now for the numbers. That negative 8 on the left needs to move to the right. It's negative, so when it crosses over, it becomes a plus 8. There. Now all our letters are on one side and all our numbers are on the other. We are so close. Time for step 3, combine our like terms. On the left side, what's 4x minus 5x? Well, 4 minus 5 is negative 1, so that's negative x. And on the right side, what's 2 plus 8? That's 10. So our super simple equation is now negative x equals 10. Now wait, we're not quite done. We want to know what positive x is, not negative x. So we just have to flip the sign on both sides. If negative x is 10, then positive x must be negative 10. We did it. We found the secret value of x. And just like that, you've done it. You've learned the basic language of algebra. See, it wasn't about scary random letters after all. It's really just a secret code, a powerful tool for solving all kinds of puzzles. Now that you know the rules, now that you know the game, the only question is, what amazing puzzles are you going to solve next?